Hey, algebra students, this is Mr. Surface coming at you with lesson 10-2, simplifying radicals. The goal of this lesson is to simplify radicals involving products and quotients. That means multiplication and division problems. So in this lesson, we're going to be working with square roots. So let's go ahead and revisit this idea of what square means and what square roots are. Hopefully by now you can be comfortable, or you should be comfortable, squaring numbers from 1 to 20. But if not, we have some help for you. So think about this. If you were to square the number 1, it's 1 times 1. That's what a square is. It's a number times itself. So 1 times 1 equals 1. Therefore, you have 1 squared unit. But if you were going to go in reverse and ask what the square root of 1 is, well, it's what number multiplied by itself gave you that number, 1. Well, 1 times 1. So here's just a list of the first 5 square roots, and you can see the square on the left, an area model in the middle, and then what the square root would look like. Hopefully you're familiar with these. 3 squared is 9. There's 9 squared units there, so the square root of 9 is 3. Okay, so those are the first 5 examples of squaring a number, and then the area model, and then going in reverse with the square root. So think of it this way. If you were to take 3 and you were to square it, 3 times 3 is 9. But if you're going to go in reverse, the square root of 9 is 3. Okay, here are the first 10. Hopefully you remember those. So hopefully if somebody asks you, hey, what's the square root of 64? You would know it's 8. Or what is 6 squared? You know that that's 36. So don't get too confused with this idea of when someone asks you what a square is or what the square root is. By now you should be pretty comfortable with that. Okay, we might go up a little bit further into 11s and 12s and 13s and up to 20 and even larger than that, but just feel free to use your calculator if you're not sure. Okay. So let's consider 2 basic radicals. The examples, the square root of 2 and the square root of 3, are the radicals that we're going to look at. When you look here, that symbol right there is the radical symbol. The value underneath the radical is called the radicand, okay? And if there isn't anything in this general area here, then we're looking for the square root. If there's a number like a 3, then we're looking for the cube root, or if a 4, we're looking for the 4th root, okay? So let's look at these 2 basic radicals and the 4 operations that we're going to work with. If we ask you to add the square root of 2 and the square root of 3, unfortunately, you wouldn't be able to do it. They are not like radicals because they're not like terms. So you can never put like terms together. For instance, if I ask you to add 4 plus x, you can't put it together because they're not like terms. The same thing goes with subtraction. If you were to try to subtract the square root of 2 and the square root of 3, you cannot do it because, again, they're not like radicals. But with multiplication and division, it's a little bit different. If you were asked to multiply the root 2 by root 3, you can actually do that because you can put them underneath the same radical, and that would be 2 times 3, and you would get the value of 6. With division, you can divide them by a process called rationalizing the denominator. Now, we're not going to get that far in this lesson. You're going to hear it in future math courses, but we're still going to be doing the process of simplifying radicals using this idea of division. And you can do it because unlike radicals can be multiplied or divided. They just cannot be added or subtracted. You have to have like radicals, very similar to like terms. Okay, the process that we're going to be using is very similar to prime factorization. So if you remember back in the day when you guys were asked to have the prime factorization of a number, you would make these factor trees and you would break this down, finding the number 36 into 2 numbers that were multiplied together. Here's just an example of 2 and 18, but you can use others. And eventually you would get down to those prime numbers and you would have its prime factorization. Same with 54 over there. If you were to break it down, again, this is just another example, but there's many other ways you could have gotten it, and you still would have gotten the prime factorization listed at the bottom. In this lesson, we're going to simplify radical expressions using a similar process, and we're going to use the multiplication and division properties of square roots. So if you look at these 3 examples, the square root of 72, well, we could break it down into 36 and 2, which would simplify into 6 times root 2, or 6 root 2. Same thing with 48 and the same thing with 125. I'm going to show you this process, but if you notice these numbers in red, those numbers are very special numbers because those are actually perfect squares. And if you can find those perfect squared numbers, you're going to help yourself out in this process when you're simplifying. Okay, so let's take a look. We want to remove perfect square factors and we want to simplify the square root of 160. So I'm going to show you a bunch of different ways of how to do this. But let's go ahead and look for the largest perfect square factor. In this case, it would be 16. So remember, 1, 4, 9, 16, 25, 36, and so on. Those are your perfect square numbers. See if those divide into the number. If they do, use it. Okay. If not, you can use other methods. From there, then, we use the multiplication property of square roots, and we break them into root 16 times root 10. We simplify root 16 because we know the square root of 16 is 4, but the square root of 10 cannot be simplified. So therefore, we leave it as the square root of 10. Now, if you notice, there aren't any other perfect square factors that could divide into the value of 10. So once you've identified that the radicand, that's the number underneath the radical, doesn't have any other perfect square factors or cannot be broken down further, then you know you've reached your ending point. Here's another example of 160 being broken down. Instead of using the perfect square factor of 16, I just divided it by 4 because I knew it divided by 4. And then what I did was, I knew the square root of 4, okay, is 2. So I took that outside of the radical, and then I broke down 40 because I'm trying to continue to break down 40 because I know there are perfect square factors in there. So 40 was broken down into 4 times 10. 4 is also a perfect square number, so I brought it out and I multiplied it by the value 2. And then 2 times 2 was 4 outside of the radical, and I still got my answer of 4 root 10, okay? Here's another example, 160. But at this time, I didn't realize that it was divisible by 16 or by 4, so I divided it by 2 because it's an even number. Well, 2 times 80. In this case, I still need to break these other numbers down, 80 into 8 and 10, to find perfect squares. So I broke down 80 into 8 and 10, but those aren't perfect squares. So I broke down 8 into 4 and 2. Well, look at that. 4 is actually a perfect square. So I took that outside the radical. Well, 2 times 2 actually creates the value of 4. So I can then find the square root of 4, which also pops out of the radical to give me 2 and 2 on the outside, and then root 10 remains, okay? One last one. Again, I just took 160 and I multiplied it by 8 and 20 underneath the radical. I then broke up 8 into 4 times 2 because 4 is a perfect square. I broke up 20 into 4 times 5 because 4 is a perfect square. And then the square root of 4 is 2, and this square root of 4 is 2. So that's why they pop out of the radical, and underneath the radical is the value of 10 still. So that's the process of removing perfect square factors from these radicals. We want to simplify the radical, and that's what we're going to be doing. You can do the same thing with fractions, okay? If you noticed here, root 64 divided by 49, okay, so 64 divided by 9, but we're finding the square root of that. Well, we can break them up into numerators and denominators, right? That's the division property of square roots. And if we do that, well, we know the square root of 64 is 8, and we know the square root of 49 is 7. And therefore, I've arrived at my answer because I simplified it. Okay, here's another example. If it was the square root of 36 divided by 49, well, those are perfect squares. So you can write them separate, and then you can simplify. Okay, there are other elevated examples that you're going to see. You might have to multiply these guys together. We're not going to get into the ones that involve variables right now. You're going to see that in future courses, but I have confidence that you'll be able to do it. But here's the process if you're asked to multiply square roots together. So if you had root 2 times 6, you could put them underneath one radical to get root 12. And then you know that 12 is made up of 4 times 3. 4 is the same as 2 to the second power. And then you take the square root of that to get 2 root 3. You might even have radicals that have values in front of them. Well, remember the commutative property. It's just all one big multiplication problem. So move things around. Move around your 2 times your 5 to get 10 on the outside. Underneath the radical, 3 and 2. Well, 3 and 2 is 6, and there aren't any perfect square factors that go into it. So your answer is going to be 10 root 6. Okay? So tips for simplifying radicals. Try to find the highest perfect square factor in the radicand if possible. It will work if you don't use the highest perfect square, but it's a longer process and you might have room for error, maybe not taking that radicand number down to the lowest value possible. Make sure the radicand does not have any perfect square factors other than the value of 1. Make sure there are no fractions in the radicand. Okay, you always have to simplify the radicand so there's no fractions. And then lastly, no radicals appear in the denominator of a fraction. So you can have a fraction like 4 over root 10, but you would have to simplify that. And again, we're not going to venture down that path right now, but you'll see it in future math courses. Okay, so I hope this helps. Please reach out if you have any questions. Join a Google Meet. Try your best. Good luck. You guys got this.